Sorry, it got muted. Can somebody confirm that you're able to hear me?
Yes, sir.
Yes.
Yeah, you're audible.
Okay, right. Good afternoon. Welcome to this workshop on machine learning for construction automation. This workshop is organized by the IAARC Workshops and Summer Schools Committee and the IAARC Students Chapter at IIT Madras. I will later on, I will ask Professor Koshi Varghese to talk about IAARC and ISAR. It's an organization which has been in the area of automation and robotics in construction for many years. And later on, our student Varun Reja will talk about the IAARC Students Chapter and its activities. I am currently the Vice President in charge of workshops and summer schools at IAARC. In the summer schools committee, we discussed about what should be the format of these workshops and what should be the content. What we decided was it shouldn't be like a regular conference where researchers come and present their research. Instead, we wanted to focus on a particular theme which is relevant to construction, automation, and robotics. And there should be more hands-on. People should be able to come and do things, learn by doing, and take back some skill which they can.
Sir, you're not audible.
And there are group discussions. So we had very heavy hands-on content in all the previous workshops. This time, since because of the lockdown, we wanted to make it online. So in all the previous workshops, we restricted the registration to about 30 or 40 because beyond that, it's very difficult to work in groups. But this time, since it's online, I didn't put any limit on the registration. So we have about 1,200 registered participants. That shows the interest in this area. And I think it's a good sign for the industry. We have more people to think about automation and to apply it to the field. This workshop is sponsored by the National Supercomputing Mission of India. Professor Rupesh Nasre of Computer Science Department of IIT is coordinating this. He has been extremely helpful in organizing this conference. So my sincere thanks to NSM and Professor Rupesh Nasre. Before we start the workshop, I would like to say something about our department. I belong to the Department of Civil Engineering, a division called Building Technology and Construction Management Division. This is our website. If you want to know more about what we do here, you can just go to civil.iitm.ac.in. This page, you can see a concrete 3D printer, which has come out of our research here. And this is probably the first 3D printed concrete building in the whole of India. So we do a lot of interesting stuff, which you can see on our website. I would like to mention something about a new Center of Excellence we have started in the department. This is a prospective Center of Excellence in low carbon and lean construction. We are looking at how we can reduce the waste in construction and how we can make use of waste in construction. So there are different activities. We have the materials group and the construction management groups collaborating in this project. We are looking at how we can make use of recycled aggregates in concrete, but it also is also about improving the efficiency of the entire process. Those who are familiar with lean will know that material is just one type of waste. There are a lot of other types of waste, equipment being idle, time that is wasted, money that is wasted, and so on. So we are looking at how we can reduce the waste in construction through the use of automation. So we are exploring the use of robots for segregating the waste. We are exploring the use of 3D printing and other automation techniques for improving the efficiency of construction and so on. When we have just got started, and later on you will find link to our center from the civil engineering website. You can come and explore what we are doing and learn more about what we are doing in this project. Now coming to this workshop, the objective is to introduce fundamentals of machine learning techniques and develop skills to select the right technique to solve civil engineering automation problems. Now we have 1,200 participants in this workshop. So we have a difficulty here because most of you are from different background with different skill sets. Some of you might be very good in mathematics. Some of you might be a bit intimidated by mathematics. Some of you might already have good IT skills to program, to use computational tools. Many of you may not have that, but I have to go with something like the lowest common denominator. At least I want 90% of the participants to benefit from this. So we will not be going so much deep into the mathematical details, and we will not be using software for machine learning applications. Instead, we are going to focus more on the applications to construction automation. Our objective will be to introduce the fundamental concepts to see what is there, how it works, why it works, where it works. So this will be the emphasis of the workshop. At least for the initial session, we will focus on this to have a qualitative understanding of machine learning techniques and how it can be applied to construction automation. Maybe towards the end, when we have more specialized audience, we can have special sessions on the use of computational tools and go deeper into the mathematics. Now, all the material related to the workshop will be on this website. If you click on this, right now there is a survey I'm doing to find out what exactly you are interested in learning in this workshop. Some of you have already submitted your responses, but at the end of this talk, I will give you the opportunity to submit your responses again. So I have a clear idea about what you expect from this workshop. And all the material will also be on this. So keep looking at this website. Every day it will be updated. Now the topics, as I mentioned, we'll first introduce machine learning, and then we will have an overview of machine learning tasks and algorithms for solving those tasks. And we have a number of case studies which will be interspersed in between the lectures. We'll have a number of examples. So this is the updated schedule. The schedule on the website has changed. I have updated it.
Sir, sorry to disturb you, but we are not able to see your screen. It is stuck at introduction page only.
No, actually, we can.
No, sir, I
share.
can actually see.
Parasit's on schedule, sir.
We can see.
able to see.
So you have some, maybe some internet problem is there from your end. Just check yourself, please.
No, sir, we can see your screen.
Visible, sir.
So it's
Right.
working.
Now I'm showing the schedule. Are you able to see the schedule?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Okay, so this will also be updated on that website, so you can take a look at it yourself. So all the remaining days we will start at 9:30 in the morning. We have a break in the afternoon and we finish at around 5 o'clock. So this will be the schedule. And the way I have organized it, you have number of exercises which will be on that website. There are about 20 exercises which you have to do. So it's not just listening to lectures, you will have to do things. And as I mentioned, right, everybody will, who successfully completes the workshop will get a certificate. So I look at how you have completed all the exercises. So only if you complete all the 20 exercises, you will get the certificate. And there will also be an award for the best participant. So I look at how you have done the exercise, and also there is a quiz on the last day just to find out what you have learned. So based on all this and your participation in the workshop, we'll identify the best participant, and the best participant will get a certificate. And for the students from India, there will also be a prize apart from this certificate. Unfortunately, I cannot send this abroad because of all the difficulties with customs and all that. So this prize will be only for the participant from India, student participant from India, but there will be a certificate for the best participant internationally. Okay, so this is about the introduction to this. Now I'll just show you this form, Google form, which you have to fill in. Just a minute, it's just loading. Okay, I'll post it on the chat window. Okay, I'll post the link on the chat window. This is the survey which you have to do for me to find out what you expect from this workshop. Okay, I'll do that in a short while. Meanwhile, I invite Professor Koshi Varghese to speak about IAARC. Professor Koshi has been is the past president of IAARC. He has a lot of experience working with this organization. So I invite Professor Koshi Varghese to make a short presentation.
Yeah, thank you very much, Benny. Let me just share my screen. Yeah, I guess you all can see my screen.
Yes.
Benny, can you confirm? Okay. Yeah, so thanks for this opportunity to introduce IAARC. I really appreciate Professor Benny has actually put together this workshop, got into so much of detail of being able to run a machine learning workshop for the construction applications for over 3 days. That's a lot of effort. I also really thank Rupesh and his team for supporting this and bringing and making it and giving the publicity so that so many people could register. This is a very important topic to us at IIT Madras, especially our research group. We've been working on this for several years, and we are happy to partner with IAARC, which Professor Benny and I are part of. which is an international, as you can see here, it's International Association for Automation, Robotics and Construction. And I have been a part of this organization for over close to 30 years now. And this would be something surprising because one would think, where was automation and robotics in, say, 1990 or 1980? And so I thought it would be a good opportunity for us to give you all a little bit of history of what this organization does and how its actually relevance continues to be there after 30 years, and it's very, very much more relevant today. So I will briefly touch upon objectives and history of IAARC, go through research trends, organizations, and the activities we are doing. I think Varun will follow this up with the student chapter of IAARC, which is actually getting much, much more attention today. Now, if we go into the objectives of IAARC, so I could go through all this text, but basically what I would like to replace this text with is this image, which kind of describes what we need to do. And you can see that this is where we've been always looking for. How does a construction site, which we see today, or a construction project, which we see today as being very messy, unstructured, whether we are doing in the design phase or whether we are doing in the procurement phase, or as you can see in this slide, the construction phase, how can we bring in more automation to it? How can we bring in more computerization to it? How can we get the construction industry actually get the benefits of all this digital revolution that's happening around us? This has been the quest for those of us who have worked in the construction automation area for our whole careers. And as we have gone, there have been stage by stage, I would say things have been improving. And definitely when we look today with all the equipment, so one of the biggest barriers to this has been that a construction site is outdoors. A construction site is subject to the environment. It's not like a manufacturing or like an office where everything is inside. But you can see here that, and all of us experience today, that the cell phones, the computing we have in our cell phones today are more powerful than what we would even have on a desktop 20, 30 years back. So we have reached a stage where this unstructured environment can actually be handled much, much more, easily with the computing we have, with the algorithms we have, with the hardware we have, with the kind of sensors we have. And this is kind of not going to go into the detail of this, this kind of cartoon, but this is where we want to head. And this is what kind of excites us. If you
sorry for the interruption, could you share it in the presentation mode?
Isn't it in the presentation mode?
No, sir.
Okay. Okay, I think I have to share my other screen. Give me a minute. There seems to be an issue with me getting onto the presentation mode.
No issues, sir. You carry on.
Now, give me a minute. Is this better?
Yes, sir. Yes, sir.
Better.
Yes, sir.
Okay. Because of my two screens, I think it got mixed up. Okay, so this, I guess this animation didn't come through. So this was the first objectives. And then this now you see is what we have read this. Okay, if I get to the brief history of IAARC, I guess what you can see is just the arrows right now. The arrow with the text. Is that what you all can see?
Yes, sir.
Okay,
Yes,
good. So actually the conference started, I wouldn't call it a conference. It actually was a meeting that started in the Carnegie Mellon robotics group in 1984, when they were trying to look at how can we address robotics. Pardon? Yes? Can you hear me, or is there a problem?
Yes, sir. We can hear you.
Okay. So this started in the mid 80s with the CMU's robotics group looking for robotics in unstructured environments, whether it was in agriculture, whether it was in construction, whether it was in terrain exploration, the military, and all of that. That is where the whole process started. And let me move this out here. And we then, and then it kind of made itself into an organization and conference about 2 years after that. Construction spun off. It used to be construction, mining, agriculture, all of that for some time. And then construction spun off into this conference we call ISAR. That is the International Symposium on Automation and Robotics in Construction. It's been held consistently since 1986 every year. You'll see a little bit of that. Today, we are a global organization with mostly academic, with a large number of universities and agencies involved, but mostly academic conference. And we have grown from strength to strength. In addition, and today a lot of the work we do tries to address digital in the field. Okay, not just digital in research or not just digital in concept. And this is where we are. And some, by doing workshops like this, definitely one of the challenges this whole group has faced is that whether it's if many of you there are civil engineers, our civil engineering curriculum does not bring in automation or computing. We probably have one class in it, but we need much more sophistication to be able to take this, even do research in this area. So how does a civil engineer actually move to being able to bring in computational concepts into civil and construction engineering has really been a challenge. And I think that's where workshops like this are hopefully inspire people to bridge that and to be able to do the interdisciplinary in a more informed fashion. Now here are some of the things we do. I think we do these kind of conferences and workshops a lot of times in an academic setting. So what you see here is a hackathon that was held in Berlin when the conference was in Berlin. There are also, like I said, site visits. It's not just automation in the lab or automation or in a computer. It's also something which we do on site. Now, here is a little bit of where we had started and where we are. And those of you who are familiar with the computing fronts from the 80s will see that kind of IAARC and ISARC has been on all the fronts, and in fact, in the 80s, actually, we started with robotics and construction robotics because the Japanese were actually flooding the market with construction robots. The Japanese, with the automobile industry boom, had said that we will do a lot of construction robotics also. That's where a lot of the interest also started. Then whether it went through the World Wide Web boom or whether it went through the optimization, the soft computing boom, of the early 2000s, the availability of mobile platforms, mobile computing, then going to BIM, digital twins, all of that, the augmented reality, virtual reality, and today, whether it's in AI or 3D printing or the fully integrated process, all of this has been a part of ISARCs and IAARCs and topics of discussion in our community. Little bit on the organization. So we have, you can see that this is it's fairly good structured organization. And as Professor Benny had said, we have different vice presidents, whether it's for conferences, workshops, industrial outreach, policy, all of these have, different roles in which, and the student chapter is one thing that started more recently, and a lot of effort is going into making those global. So student chapter is not just not just the Indian universities, but also you connect with the global equivalent student chapters. IAARC, I think the easiest way for you to explore is to go to the social media today. I don't think we have been as active as we should have, but you have, whether it's the Twitter or the LinkedIn, I'm going to go through these pretty quickly. We have, different kind of newsletters which talk about what is there. We have a website. I think the website is well developed. I think you should go to the website and see what is there. And one of the real pluses on the website is that you can actually download any publication from the conference in 1984, starting from 1984, any of the conferences in ISAARC, you can actually download the publications. We made it open access. Some of it is just scanned paper, some of it is, the later years are digital, but this is a repository that's open to anyone who's interested in this. Okay, you just have to access the website and most of it is indexed. We are now coming out with a YouTube channel where we will put material like what we are recording today and more. And that should be, again, it's kind of coming soon. Okay, it's not yet populated. We have a lot of activities, like we had said, whether it's, the symposium, regional workshops like this, hackathons. We have an associated journal called Automation in Construction, which is one of the leading journals today in construction and civil engineering because there's so much interest in it. And then there is also the student chapter. So Varun will definitely talk, I know, more about the student chapter because he and his group of our group of students at IIT Madras have been driving it. And let me stop with that. I look forward to interacting with you all sometime during the workshop, might be in a later session, and probably catching up you with an IAARC or a physical workshop, which we could probably have after all the pandemic phase is over, and hope all of you are keeping safe. So with that, let me stop and hand it back to Benny.
Thank you, Professor Koshi, for this the introduction to all the activities of ISARC. I hope you will find it useful to supplement what we are covering in this workshop here. Now I invite Mr. Varun Reja. Varun Reja is a PhD student who is looking after the student chapter at IIT Madras. Varun, please make your presentation.
Sir, can you give me the rights to present my screen? Currently, the sharing button is not enabled. Okay, now I can share it. So, hello everyone. This is Varun, as Benny sir already introduced. So, you already have a good background about what is IR. Professor Koshi introduced that, and we at IIT Madras got motivated through one of the conferences which was held recently, and started a student chapters 2 years back. So this is a second year running, and yeah. So I think I will skip this slide because Professor Koshi already introduced what IAARC is. It's dedicated to automation and robotics in construction, and it's a non-profit organization. And there are a lot of members from academia and some members from industry. So last 3 versions of ISAR were held in Canada in 2019, Japan in last year in Japan, which was held virtually. And this year, ISAC 2021 will be held in Dubai. So this is a great opportunity for all the scholars from MTech or BTech or PhD scholars to showcase their work and get feedback on their work. It is really a great conference. I had an opportunity to go to ISARC at Banff, and from there interacting with so many people, I got motivated. And with mentors like Professor Benny, Professor Koshi, and Professor Ashwin, we got an opportunity to start the student chapter over here. So our motivation was just to encourage and facilitate the concept and technical development in automation and robotics in construction, and to encourage students and scholars which are coming up to pursue research or pursue interest in this field. So generally we do monthly activities. We have workshops, we have discussions. All over the year, we have quite a handful of activities which we do as a group. And we also invite people from the last event. We have making it open to all. So we are doing it online. And we will be publishing annual newsletter for each year. So last year we published an annual newsletter. And Right now there is talk which is going on to collaborate many students chapter which are across the globe. So this is the newsletter which you can find on IARC LinkedIn webpage. It is available there. It says about what are our aims, objectives, and what activities we did in the last year. So this is like an annual report. So we have we started with after ISAR 2019. We started with an introductory session where we had an introduction about ISAR and IARC given to the scholars, and we got a very motivated team of around 15-20 people which work in this department. So we had workshops like laser scanning workshop. We demonstrated a live laser scanning session, and one of the scholars volunteered to who had an expertise in laser scanning volunteered to give knowledge on that. We were sponsored on a trip to Autodesk University, India, which is an conference, AU India conference, and it showcases many state-of-the-art technologies like AR, VR, and even latest IoT technologies. And it is a very great experience to have. So we were sponsored by IIT Madras Civil Engineering Department, and we also have speakers from industry. So Mr. Aditya VS is one of the alumni of IIT Madras, and he with his team, as you might have already seen in Professor Benny's presentation, have developed the 3D printer in collaboration with IIT Madras. And so we had a discussion session with him. He presented what about the 3D printing technology they have been working on, and we also had a demonstration of a 3D printer. So this was the and we also had few of the international speakers in the past, like Professor Joseph Lewis from Oregon State University came, and Professor Pang Jo-chun from University of Tokyo came to talk on AI and deep data platform for infrastructure management. So these kinds of events we generally keep on having. Then in recently we had a meeting for collaborating all the IARC chapters. So when we started the chapters, after that, other universities like University of New York campus and CMU also started to bud their chapter in their own way. So we are having a meeting. We had a meeting now so that we can collaborate and share this data. So the workshops can be, and many people can get benefited from them. So here are our faculty advisors, which mentor us at IIT Madras. I'd like to thank all of them to give opportunity to actually host this workshop and also give guidance to us. Here is our team. This was the team for 2019-20 session with our coordinators and our working members. And this is our team for the current year, 2020-21 session. So all the members actively participate. We have a social media platform. You can easily find us on IARC at IITM, LinkedIn webpage. You can connect with us. And there we frequently post the workshops or events which we are going to have in near future. And we also received a direct appreciation from our student body, which is a great motivation from us and for us. And thank you for listening. And if you want, I will just have you can scan the QR code, or you can directly follow us on LinkedIn IARC at IITN. So that was it from my side. Thank you. I hand over to Professor Benny.
Thank you, Varun. So I hope you had a good idea about what our student chapter is doing. So those students from various colleges here, if you want to start up a student chapter, we will be glad to help you. You can contact Varun. He will explain to you the procedure. Okay. So now we move to the main part of the workshop. I hope you have seen that website. I'm just going to share my screen. Just a minute.
Sir, I think you're muted. We can hear from your side.
Sorry, I was muted. Sorry again. It's the second time it's happening. So let me just come back to this page. So this is the web page. You have received the link. So you just reload it. I have added the link to the exercises which you will be doing during this session and the coming sessions. And this is the link to the survey. If you have not done that, please do it, because I need this to see what is interesting to you from this workshop. So right now 148 have submitted your responses. So I see that most of you, there are a lot of people who are interested in knowing the mathematical details, but about 35% is just want to know a little bit about mathematics, don't want to go deeper into it. So we will see how it goes. Probably in the initial sessions, we will skip mathematics, but towards the end, we will go a little bit deeper into this. And I see that a lot of you are interested in the use of software tools. But unfortunately, you need to have certain background. If you're using some tools like PyTorch, you need to understand, you need to know a little bit of programming in Python or in MATLAB or R, which many of you may not have. So we won't be going too much into the software tools, use of software tools. But I'll give you a small demonstration using simple tools. Okay? And most of you have agreed that fundamentals is more important. So this is where we are going to emphasize on. So I think this is more important to understand what goes on behind all these black boxes. So we don't want you to just use black boxes. We want you to understand how it works, why it works, and so on. And I see 50% are completely new to machine learning. So that will be the main emphasis to introduce the fundamental concepts. Okay, so thank you for your responses. And we will be doing a lot of these exercises during these sessions. So this is the link to all the exercises. Don't try to do all the exercises now, because I need to first introduce these exercises to you. So I'll tell you when to do each of these. Okay, but you can take a look at what is there. Okay, so now I'm going to move to the first lecture. Is an overview of machine learning techniques. And as I mentioned, the why we are doing this, because machine learning has huge potential for solving practical civil engineering problems. And to solve these problems using machine learning techniques, you need to have considerable knowledge and experience, mainly to formulate the problem correctly and apply the right techniques to solve that. Computer scientists won't be able to do it because they don't have the domain expertise. You need domain knowledge to formulate the problem correctly. So you need people who know more both about machine learning techniques as well as the practical applications. So you need both knowledge in order to apply machine learning successfully. So this is what we are planning to do. So those who are already civil engineers, they should understand a little bit about the fundamentals, the theory behind machine learning, and you should be able to apply it to practical problems. Now, before we discuss about machine learning, we need to first examine what exactly is human learning. This is an image I received through WhatsApp. I'm sure most of you have seen this. This is one of the pictures, that gets forwarded many times. What I like about this picture is that it's a very good representation of public perception of the construction industry. When we think about construction industry, definitely it's not a high-tech industry. That's not the perception people have. We think it's a low-tech industry, which depends a lot on manual labor, and most of the time this labor is sometimes illiterate, but not a very not with lot of skills, and people do a lot of stupid things on the construction site. So you can imagine what happens if this person slips. By rule, you are supposed to wear a safety harness so that even if you slip, you don't fall. But see how he has used a harness. So this shows, the kind of stupid things we do on the construction site, and we just don't care so much about safety. We don't understand what are the safety requirements. So now we are talking about using machine learning, using artificial intelligence, using automation, and you can see the contrast. From this stage, we want to go into a high-tech industry. It's a long distance to travel. Now, coming back to learning, we learn from experience. So unfortunately, this person won't have an opportunity to learn from experience if he makes a mistake. But in general, if we make a mistake, we try to avoid the mistake in the future. At least other people will be able to learn from his mistake. And we try to adapt our actions in the future so that we don't make the same mistake again. So this is an aspect of human learning. We learn from experience and improve our performance. And how do we learn? We learn by acquiring knowledge. And this knowledge is acquired either from others, or most of the time we do it by self-discovery. Especially small babies learn a lot of things by discovery. They explore various things and they see that things can be done even for the use of their arms and limbs. They have to do a lot of exploration. Said that, they randomly try out different things. The brain is trying out different things, and they realize they can move their arms, limbs, and all that. So a lot of learning, especially at the very infant stages, is through self-discovery. And then using all this knowledge, our performance improves. So this is an important aspect of human learning, to be able to learn from experience. In the 1950s, people started thinking about whether we can make machines learn just like human beings. People thought you can develop processes which simulate human thinking processes, and we can implement these on computers, and computers will be able to learn exactly like human beings. There's a famous book written by Herbert Simon. Herbert Simon is a Nobel laureate in economics, but he has developed a lot of these fundamental ideas related to artificial intelligence. So in this book he has written, called Sciences of the Artificial, it was written in the 1950s. He speaks about, there is a science called artificial intelligence. He proposes that we can try to think about how human beings think and implement similar processes in computers, and computers will be able to learn just like humans. And a lot of things we do today in artificial intelligence can be traced back to some of the ideas which he proposed in the 1950s. And over the last 50, 60 years, there have been a lot of work in this area. So in the 50s, they thought in another 20, 30 years, we will be able to develop thinking machines, machines that can think exactly like humans. We are not there yet, but there have been a lot of successes in automated control, recognition system, face recognition, handwriting recognition, natural language processing, and so
Sorry to
on.
disturb, sir. You are again muted.
The audio is there. We are able to hear.
You're able-
Actually, he has not muted the call. You hear it.
So are you able to hear now?
Yes, sir.
Yes,
Right.
sir.
Okay, to see where we have reached, I'm going to show you a video. Many of you might have already seen this video. This is the robot called Are you able to see the screen? See the video?
Yes,
Yes,
sir.
sir.
Okay, I turned off the audio.
Yes, sir. It is muted now, sir.
Right, I've turned it off. So what I want you to see from this video is, what are the smart things this robo is able to do. And I'm going to stop it. It's on the internet, so you can easily search for Boston Dynamics robo, and you can see this again. So let me stop this. Now we will do a small exercise. So you come to this page, click on exercises. You might have to reload it. You reload it and then click on this form. So these are small exercises you will do during this workshop, mostly to think and answer something. You don't have to use any software or you don't have to do any calculation. Mostly these are exercises for thinking exercises to find out what you understand and also to explore and develop some ideas related to what is being taught in this workshop. So just fill in this. So simple questions. So what are the intelligent aspects of the behavior of the robot? What you see from the video. See if there is anything smart or intelligent. Then next question, do you see any application of this robot in construction? Okay, whether it can be applied to construction, why we are able to apply or not able to apply. So you submit this and you need to complete all these exercises. If you want to get the certificate for the participation, it's mainly to find out what you understand from what we are covering in this course. So spend about a minute or so to send your response, and we will go through your response, see what you have answered. Okay, so some people have written obstacle avoidance, very good. So that is really smart. You see that the robot stops when it thinks it's going to collide with somebody. So cooperative behavior, opening the door for another robot to enter. Recognizing human facial expression, I don't know whether I might have missed it. Maybe it does that. Smart, adjust with environments in extreme condition, ability to navigate is very good. These are really very, I would say this is the pinnacle of success in the area of robotics. It's really very smart with respect to navigation, mimics human behavior. Is this is not a humanoid robot. This is more like a dog, a quadruped, but still it mimics human behavior. Right, you can see They have used artificial intelligence. Yeah, recovering from falls, more flexible and smart, path planning. Very good. You have really thought about the intelligent aspects of this robot. So this is really good. So now let us see what application you see in construction. Carrying loads. If you go through this video again, you'll see that it can lift about 14 kg. It's not a lot. In construction, we have to lift tons of load, but maybe in a few bricks or for small loads, it's possible. We can navigate difficult terrain. Yes, we can do. Learns to mimic human facial expression. Okay, I don't know what is the application of that in construction. So it's definitely, it can do a lot of things. Welding, road construction is. The computer vision aspect is, so you can use it for monitoring on the construction site. If it's a very dangerous situation, the operator may not be able to go and inspect, especially if there is some accident and you want to see what is the situation. We can send this robot to find out what is happening, to identify construction hazards, problems. Yes.
Sorry to interrupt, but where I cannot find this Google form.
You click on this. So this is that page, iarcmlworkshop.web.app, which is sent to you. You right click and click reload. So you should see this link called exercises.
Okay, sir. Thank you.
Okay. So work in harsh environment, site inspection. Okay, good. So you have thought about it, and you see there are a lot of possibilities for using in the construction on construction sites, but I don't see any responses about why you cannot use it in construction. Anybody who thinks it cannot be used in construction? Okay, so let me give my answer to this. Definitely there are, yeah.
Because of cost, number one.
Right,
Number two
exactly.
is
That's the point I would like to bring your attention to. So
standardization of the process.
and
And
what? Yeah.
runtime is 1.5 hours.
Tell me again.
Maybe because runtime is 1.5 hours only.
Right. Okay.
So
Yeah,
there
there
are
are
tons
still
of
some limitations. There are still some limitations because of the current batteries that are available and so on. But
dynamic environmental constraints, sir.
Yeah, for example.
So harsh weather conditions, change of climates, or
No, this is meant to work under really harsh conditions.
Yes, sir.
That's what they claim.
Yes, sir.
Okay, so the cost is really a big issue here. A simple KUKA robot with 6 degrees of freedom, I'm told it costs about 1 million the US dollars, and this is several million US dollars. And imagine you buy one for your company and you use it 24 hours a day, you make 100% utilization of this robot. Still, you can work out how much return you need to get in order to pay for the cost you have incurred, for the capital cost you have incurred in purchasing this. So this is a problem. So I think these kind of general purpose robots, which can do all kinds of tasks, they have limited application with the current level of cost. Maybe the cost will come down in the future, but At the moment, it doesn't look like, it will be cost effective. Finally, we are looking at sustainable construction. We are also looking at economic sustainability. We want to build affordable houses. So if you increase the cost, capital cost too much, we may not be able to improve the sustainability of construction. Today, construction costs are still very low. If you look at the cost of concrete, we are paying something like rupees 2 per kilogram of concrete. You get only that in Amma canteens in Tamil Nadu for food. We don't get anything that cheap. And now we are buying $1 million equipment and try to improve the efficiency. It doesn't make sense from the economic point of view. So that is a big issue, I think. So, we need to look at cheaper solutions, maybe not general purpose robots, which can do all kinds of tasks. It became so expensive because it's very too smart and can do too many things. But we need to start looking at whether we can build simpler machines. We talk about appropriate level of automation. Maybe we don't need this level of sophistication. We need simple automation for construction. So this is something we will explore during this workshop. Now, what exactly is construction automation? I've taken this definition from somewhere. I modified it a little bit myself. So it's the use of mechanical and electrical systems with computer control for performing construction activities with minimum manual labor. Is one step over mechanization. Mechanization is the use of mechanical tools for construction activities. Now we also want to make use of computers. We want computer control in this. And if you look at many sophisticated equipments today, there is already computer control. There is a microchip which is controlling the equipment. So the emphasis is more on computer control for performing construction activities. And why we want to do it? Of course, we can improve the productivity. Today, all of us are aware of the low productivity in the construction industry. There are studies which have shown that about 30% of money spent on construction is just wasted. There are different types of waste. We talk about material waste, the time that is wasted. We have a heavy equipment which costs a lot, which is lying idle because of poor planning. We are wasting money. So there are a lot of different types of waste, and people have shown that about 30% of money spent on construction is wasted because of all this. So you can imagine, we are talking about $1 trillion industry, and also the wasting about 30% of that. So how much of work we are able to achieve with the money that is wasted? How much of construction we are able to do with the money that is wasted? So we have a social responsibility to think about improving the productivity in the construction industry. And then you talk about quality and reliability, since we make use of unskilled labor. Quality is not that great. So can we improve the quality and reliability? We already spoke about safety. Can we make use of machines where it's not so safe for human beings to work? And also, we need to also look at the working conditions of workers. So there are today they work under very pathetic conditions, under rain and sun and all kinds of dangerous situations. People work. Now, can we make use of machines to do this, where the working conditions are not so great? So there are many reasons why we want to use machines for in the construction industry. And especially in India, we have a severe shortage of housing. We want to build millions of houses to meet up with the demand. And we are not able to do it because it's heavily dependent on manual labor today. And there is scarcity of skilled labor. Again, there are studies which have shown that 90% of the projects in Chennai are delayed because we don't have people to do the work. This comes as a surprise. We are talking about a country which has 1.4 billion people and lot of labor, but construction industry, construction is delayed because we don't have people. It's because of the use of migrant labor. The people migrate into cities, and when there is some activity going on in their villages, they suddenly disappear. Especially during this COVID pandemic, there was the mass movement of migrant labor back to their villages, and suddenly everything stopped. So we have a lot of constraints because of the use of manual labor. So automation will not only help in decreasing the time of construction, but there are also a lot of other benefits. It will reduce safety hazards and risks involved. So we are thinking about using advanced robotic systems which help construct buildings just like machine components are manufactured in factories. So I have another video here. It's about automation in the automobile industry. It is interesting to see what they have been able to achieve. And I want you to start thinking about whether we can do these type of things in the construction industry, especially in the prefabrication factories, whether we can adopt this level of automation. So I just play this video. I'll mute it. So I'll give you some commentary, so you can look at the kind of robots that are used for the assembly of automobiles. See the kind of difficult maneuvers these robots are making. Okay, I'll stop playing this just to give you some idea about what they have been able to achieve in the mechanical engineering domain. Now, we also want this type of technologies to come to the construction industry, especially in the prefabrication industry, where we can there is a lot of potential for adopting automated technologies. Now, what we can do, this is another video of a bricklaying robot. This was developed by the startup company in Kochi called Craftsmac. They have been interacting with us right from the beginning, especially Professor Koshi had been advising them right from the beginning when they started this app. I visited them a few times whenever I went to Kochi. And it's really interesting because this was completely made from scratch. Even the motors were custom designed and custom fabricated. It's not commercially available robot. They are not used to it because they were not found to be suitable for this. They had to really make it very compact. So they had to redesign even the motors. So I'll play this video to get an idea of what we can achieve. And I would like to say that this is not just a research piece, a showpiece. Shapurji Palanji, the construction company, is interested in this technology. They are testing it for their residential building construction. So it's under testing by a construction company. So let me play this video so you see what we can achieve with creative people thinking about automation. Okay, so you can see that even in the construction domain, people have been able to introduce robots of high sophistication and using machine learning. Now, I'll just complete this and then we take a break. So when you talk about automation, now how do you implement automation? So these are some exercises we do when I do the physical version of this workshop. Participants work with controllers, sensors, and actuators. So what you see here is a controller called an Arduino controller. This is something, it's very cheap. It costs only about 1,000 rupees. In dollars is about probably about $20-25. And this has a microprocessor inside. And you see on this side, you have some analog input channels. You have a set of input channels, set of pins to which you can connect sensors. And on the other side, we have a set of output channels where you connect actuators. So a control system is exactly like a human body. I take this analogy of human body, which is interesting. We have our sense organs, sensors, eyes, nose, and all that. And then we have a brain which receives signals through the nerves from these sense organs. So for example, I see a dog or let's say a tiger running towards me. There have been reports that there were some leopards were spotted in residential areas in Mumbai. So let us say, some dangerous situation. So my eyes sense, sense this, it sends signals to my brain. So now brain starts analyzing this data and it finds that, it's a situation that is not so safe. So it starts looking at what kind of action to be taken. So some process, some thought process is going on in the brain, and then it decides maybe the best option would be to run away and close the door. So it sends signals to the actuator, and the actuator takes some action. My arms, limbs start moving and perform some action. So this is exactly what happens in a control system. So here we have the controller, which is like equivalent of the brain. And you have sensors which are connected to it. So we have the input channels to which we connect the sensors, and these sensors typically produce either a voltage or a current. This is how we communicate today in using electronics. So we have sensors which produce a voltage, and the controller is able to read that voltage. So the sensor might produce a voltage in the range 0 to 5 or 0 to 10. And this controller is able to read what exactly is the voltage at each of these pins. Now it has to convert this voltage into the parameter. So that is the calibration. Using the calibration, you convert that parameter into that voltage into the parameter which you want to measure, either temperature sensor or infrared sensor. It converts into appropriate units, and then it has to do this analysis. It has to analyze the data, and then it has to take a decision what needs to be done. And so you might say it might actuate some motor. So we want to operate a motor. So it produces the output voltage in one of the output channels. You decide what the program, what it should do. So you write a program, you upload it onto the microcontroller, and the microcontroller keeps processing the input and decides on what should be done. And it produces this voltage on the output channel, and you will see the motor the performs according to what you have, the instruction you have given in the terms of voltage or current. So this is a control system. Now, if you want to develop something as intelligent as that robot craftsman I saw in the Craftsmack video, there are different stages in which you can apply intelligent control. First, in pre-processing the data. You get a lot of data from sensors all the time. You get continuous series of data from the sensors. Not all of it is useful. For example, you have a CCTV camera which is recording everything that is happening. Most of the time, it's just recording the surroundings. Everything is still. It's not interesting. And then suddenly you see something is moving. Probably somebody is trying to sneak into the building, or maybe some animal. Something is happening. Then it becomes interesting. Okay? So you need to pre-process to the data and to find out what is interesting. First of all, you need to remove all the anomalies and outliers. There are a lot of data points which are corrupted with noise. So these have to be eliminated. So we have today intelligent algorithms which can detect anomalies and outliers. So for pre-processing, we need some intelligence. That is the first stage. Then once we get the actual data, we need to analyze the data, and we need to have an accurate evaluation of the environment. So again, this requires a lot of intelligence, because it's not clear what is interesting, what is important. So this is the next stage. And the third stage is the control logic. By using this data, we need to have a system for intelligent decision making. We need to decide what needs to be done. From the data we get, we sense the surroundings, we sense the environment, and based on that we have to make a decision, a controlled decision. So that is another stage where we might use machine learning. And then you perform the action, And after you perform the action, we still need to analyze the feedback. We need to find out what exactly has happened. Has it the situation changed for the better? So again, we need to get data from the sensors to see what has happened after you have made the control action. So this is the process of continuous learning. So you will see that in any intelligent system, there are a lot of places where we can apply machine learning. Okay, so now we'll take a break. We will start, we will come back at 3:45. That is in 20 minutes, we will reconvene and we will continue this lecture. Meanwhile, if you have any questions, we can quickly, I can quickly take a few questions. You can
I have one question, sir.
chat box.
I have one question.
Yeah.
The question is, how would you see the construction industry in India? Because if you compare with the automobile industry, so there the mechanization is 70% as compared to construction industry. So what is your rate? Means how Indian industry, construction industry would work in terms of mechanization, so that the professionals are ready to learn all these techniques and all these technologies to ready with the new skill set. So what is your comment, sir?
Right. So I think there is a big difference between heavy construction and the small scale construction. See, the kind of work which companies like L&T are doing, in the nuclear industry, in the metro, there is already a lot of mechanization, if not automation. For example, the operation of the launching girder. There are a lot of cases where they are using really smart equipments and the use of actuators. I'll show some examples later on. So the situation is very different whether you're talking about low-rise construction of residential buildings. It's heavily dependent on manual labor. Whereas if you look at the more high end of construction, the construction of metros, nuclear power stations, and so on, there is more use of automation. So you see this big gap. I think it's all dictated by the cost. It's not economical to use heavy machinery for the small scale construction. I think that is the problem. But things are going to change. Labor is not going to be cheap all the time. The labor costs are going to increase, and people are going to be more aware of the conditions under which people are working today. So once that realization starts setting in, I think more people will start thinking, and many people, the people have not realized that there is a lot of savings to be made by the use of mechanization, especially in housing. For mass housing, definitely there is a lot of potential, but people have not realized that. So I think things will change. We need to start thinking about construction like manufacturing, where we make use of ready-made components, and that's where the efficiency is going to improve. But already we are seeing it in the heavy construction. It is the people are already using it. But I think in the near future, you should see the more prefabrication and automation.
Hello, sir.
Yeah.
Sir, actually, I'm going to join the IIT Madras BTCM course, and I'm really interested in learning more about construction automation. So I'm asking if before joining the MTech program, should I go through basics of machine learning or in these 2 months?
We have a lot of courses. We have courses on smart building. We have courses on machine learning. You can read. There's no harm in that. But there are a lot of courses which you can take once you join.
Okay, sir. So actually, I don't have any basics in machine learning. So I was thinking like, should I develop in the meanwhile these 2 months before getting admission, or after joining, I'll be able to develop?
Yeah, you can. See, this is an introduction to machine learning. This whole workshop is an introduction to machine learning, and there are a lot of other online courses also you can take. You can write to me. Yeah, just write to me. We can discuss.
Okay, sir.
Okay, if there are no more questions, we will take a break and we will reconvene. You will get a lot of time for asking questions. So don't worry, even if you're not able to ask now, later on, and I will give you time to ask questions. Okay?
So what's the way to connect to you?
Pardon?
So what's the way to connect to you? Like mail or anything else?
You can write to me, just search for me. You can easily find my email address on the department website.
Okay, sir. Thank you, sir.